Eugene, and I will be your presenter today. Our issue is mill turn. In the last years, SolidCAM developed a very powerful module. We call it the mill turn module. But in the last 3 years, this module became the most important, almost the most important module that we develop and we improve in every version, and also you can see change in every service pack that we send. So we already see in the previous webinars how SolidCAM deal with and support all standard mill turn machines, horizontal turning machines with a spindle in left side, spindle in right side, one or two upper in the upper turrets and a turret on the lower side, lower turrets. So this already see in previous webinars. Today I select another example, mill turn machine, but in the past we defined those machines as only a milling machines, 4 or 5 axis machine, milling machines. Today all those machines, all those old series machines, 4 and 5 axis milling, they become to be a mill turn machines. Why? Because the manufacturer add a spinning option on the table, on the 4th axis, and you get a new series of the mill turn. And we call them milling machines with turning option. So for today I select an example. I have an Ibarmia machine from Spain, I think, with a very large table, a 5-meter table in X and Y-axis. Also, all axes they are on turret. Z, we have the B-axis and C-axis on the table. So what we have here, we have a table, a milling table, a non-moving table, and with a combination of a rotary table. Now, here, the manufacturer add the spinning option on this table, can be used as a 4th axis or as a turning table. We will define this machine with 2 sub-machines. This turret can work with the rotary table, is one sub-machine, and the turret can work with the milling table, a non-moving table, as another sub-machine. And here we can define operation of turning and milling up to 5 axis. On the milling table, a non-moving table, we can define only milling with also with some positions on B-axis. That means around we can define operations on faces around Y-axis. I select this part. It's not a very difficult part, but we have here a possibility to define milling, turning, grooving, drilling, and I want to machine this part from both sides. I will start with the setup. Now, first of all, let's see the tools. I will use tools with STL and shank, defined as STL. So the tool is type insert only. Also internal turning, STL, holder and shank, and another internal turning for finish, a grooving tool, grooving and cutting, drill, a milling tool, a 10 millimeters end mill, a 6 millimeter end mill, and a 4 millimeter drill, and another end mill 3 millimeter and another 3.5 millimeter drill. For all tools I use steel holders. I didn't draw it. I just download from tool manufacturer websites and just add them to SolidCAM STL tool library. I can also always come here to this tab holder and define the new tool and select an STL that I download and define in our library. So these are our tools. In order to work in two different places, I will define two setups. I have one setup where the part is positioned on the rotary table, and I have the second setup where the part will be positioned on the milling table to work from the back side. I will start with turning operations, and here what I want to show you, let's see the geometry. I want first to remove the material on the face. So I define a geometry this line using modified geometry to extend up to stock, automatic extend. The tool, let's see the tool. I select the tool, but now I have to position the tool in the correct place. So my machine, if I'm going back to machine simulation, is very limited in X to work in the right side of the table. That's mean if I want to work in the right side of the table, I don't have very much place here. So I always prefer to work in the left side. How I do this with SolidCAM? First, in the picture we see a standard picture of the part in the standard plane rotation with Z axis horizontal and X vertical, and now I have to select the position of the tool around the part here. Now what I'm doing is I'm rotating the part with the same position as in the picture, and you can see this tool position that I select here is the same now on view. Also you can see here, you can help with this view, put the tool with the coordinate system X and Z. As the part will be on the machine, and you can have you can see the position of tool if it's correct or incorrect. Now let's go in this way. The part will be placed in the machine space in this position with X horizontal, Z vertical up. So if I want to work here in the left side of the part, I select this position for the tool. If I have enough place to work here in the right side, I select this position of tool. So when I select this position, now I will get a negative tool pass. I work on X negative. Let's go to link. What else I can define here? The approach and retract point. Very useful options in turning operations. I want to define a point, and from this point the tool will go to the start of tool pass, and from the end of tool pass also will go to retract point. So I define go direct from diameter 220 and Z 10 millimeters. The part is almost 200 millimeter diameter, so 220, 10 millimeter offset, it's enough, and also in Z direction. And I define it to go direct. So the tool will be positioned here and go direct to start of tool pass. Remove the material on face, and make a retract only in Z, as I define here, only Z 10 millimeters. This is the way that we use the tool mounting here. Select the position from which side of part I want to work. Now the second job will be turning on external diameter with the same tool. This is a rough tool. So here I want to work also in the left side of the part. Now, why I select this position? You see, if I'm placing the part with coordinate system as in the picture, I have exactly this position that I select here. Link, I also use this 220 diameter approach point, and here also for the retract point go to the same position. But how? X first. That means first retract, you finish the toolpath, retract in X and go up in Z axis. You can see a movement, a direct movement from the approach point to start of toolpath. We have the link normal and tangent. I define also a normal 1 millimeter plus tangent a 2 millimeter extension, and retract on X and Z axis. So we remove the material on face, we remove the material on external diameter. Now I want to remove the material inside. I will use an internal turning tool. The geometry show I define here. We see the rest material. All this material should be removed in this operation now. Tool. Again, I always want to know what is the best position to work with the tool. Rotate the part as in the picture, and the position that I select here is position of tool on part. Why? Because I define here the geometry, yes, but I want to work in negative side. If I want to work here, I select this position. Now we will have a positive toolpath in X. Technology also is very important to select internal. In the previous operation I didn't show you. We select for the face, we select face front, and when I work on external diameter, I select long external. Now for internal, we select long internal mode. Link. Here I want to position the tool for in an approach point in an 80 millimeter diameter, because my stock, I define the stock as a cylinder, stock show on model, with a drill with a hole inside. This is our start stock. So I want to position the tool, as I say, 80 millimeters diameter inside, and from here go direct to start of toolpath. At the end of toolpath, retract only in Z 10 millimeters with additional tangent and normal extensions. As we define in the job, from approach point go direct to start of toolpath, and all the rough operation, all steps. Last movement is only Z to 10 millimeters retract. That's exactly what we define. Now I remove the material on face, outside, inside, rough. Now I will start to define the finish operations. Show on external, I will finish the part external with this internal tool. I can work also internal with this tool. I can work also external, yes. So I define the geometry here, but because of the position that I select here on the part, my toolpath will be in the left side of the part, negative side, negative X. Technology, long external, and link, I use the same link, 220, diameter, and Z 10 millimeters. This is our finish. I continue, excuse me, I continue to define finish operations now on face with the same options, the same tool, but here what I define different is how I want to work with this tool. Let's go to geometry. Geometry is this line as we define also in rough operation, but I also want to work in left side of the part, in negative zone. So I select this position, and if I place the coordinate system here in the view, you can see also additional angle minus 38 degrees that I defined. Why? Because I want to position the insert with this edge vertical to our geometry. Link, the same link, and retract only in Z. We'll continue now to finish the internal side of the part. Here I divide all this internal side in several operations. I will operate, turn this surface and this surface, chamfer and this diameter first, up to down. Another operation will be here on this floor from internal to external, and I will show you why. And this, okay. The tool. I'm going to work here, and when I want to make this floor, remove the material on this floor and chamfer, I don't want the tool to come down and go right, because if I have 0.2, 0.3, maybe 0.4 millimeter rest material on this floor, but here the insert have only 3 degrees release, so even 0.2 or 0.3 millimeter, that will be a few millimeters, 4 or 5 millimeters on the edge. So a lot of pressure on the edge, down edge of this tool. So I want to work from inside outside. Because of that, I will divide the geometries in several operations. With approach point and retract point, go to 80 millimeters inside diameter. The first finish operation on internal side is from approach point, go directly on X and Z axis to start of toolpath, go down, retract, and go directly to the retract point. The next operation, I will simulate from approach point, from inside, go to outside, go up a little bit, 1 millimeter, and retract to the retract point in both axes. Those options in operation, as you see, they are very useful and very varied. You can select direct, only Z, only X, X first, Z first. From previous operation, that we have a previous operation position, go from previous operation to the point that I define. Also X from previous, Z, and optimal. Have a lot of options here that helps us to define a toolpath, a very safe toolpath, and also economic sometimes when you want to make the short moves from operation to operation. The next finish operation, I will go here on this diameter down with the tool, and retract to safety. And the last one on this floor from inside outside. Again, from retract point, go direct to start of toolpath, up 1 millimeter and retract. And this way I make finish in internal part. What we have left here is this groove, a lot of material to be removed. Simulate the hotcut. Go from approach point to start of toolpath, and retract to the same point. Now let's make a machine simulation and see this behavior also in machine simulation, more detail with the tool, with stock. We see here the stock. Let's make this stock transparent, and I want to see also the part. This is the fixture on the table, and holder with chunk, the tool insert only, as we define from the approach point to start of toolpath. Remove the material on face. Now remove material on side. Here I didn't reach the end of the toolpath, the end of material, because when in turning this fixture is rotating and I don't want to touch the fixture with the tool. So I leave here a small, I think 0.5 millimeters material that I will remove it from the other side. Now internal turning. And we start with the finish process. All tools are, as we define in tool table, STL, holder and chunk. External diameter, finish. And now we define a 38 degrees angle to have this edge of the insert perpendicular to the geometry. And I remove the rest material on the face. Options on the machine with B angle and spindle tool rotation in the spindle, they give me a lot of possibilities, and the user can select what is the best technology for his part. internal turning now. For finishing, I finish first as we define the chamfer and this diameter with a retract. Now this chamfer and the floor inside outside, with always with a retract to a safety position. Go down and finish this diameter and the floor. Grooving operation. Let's see. 1, 2, 3, and the finish on walls. It's a down-only finish technology. That's all. We finished the turning process on this part. Now we are going to start the milling operations. And first I want to make some drills here to remove material, and here in the drill that I will do, I can enter with the milling tool after and remove the material in the slots. Also for milling, we use the STL holders, and we start to drill one drill in each slot. Next operation is removing this material here and here and here with the 3D eye machining operation. It's a 10 millimeter end mill. We remove the material from inside outside. Rough operation. Let's make it faster. We can hide the tool path. So we remove the material. The next operation is to remove here this material and here. In 3D eye machining is very simple to use. This is the target, this is the stock, remove the material, define the levels, work area. A very fast operation to define. Now I will start with 2D eye machining operation to remove material inside the slot and use the pre-drill operation that I have done before. The tool is going inside the drill, inside the hole, and start removing the material. 2 steps. Here I have also material not removed after 3D eye machining operation. that I will remove also with 2D machining and with pre-drill option. And we have also here some material to be removed on these side entries. With the same tool, 6mm diameter. Now finishing. Okay, let's select all those operations together. And start finish. Also the finish in slot. And on the side entries. Now I finish milling, I finish turning, I finish milling. Now I will start to drill. So first I will do drills on this face. And for drills on side, on this diameter on, and also for internal diameter, I will use only one operation, multi-axis drill. Here we have definition, edit. We have three groups of drills. Group 1, that they are the same diameter, but maybe differences on levels. So one group is this, and the second we have here the drill with the same diameter but not the same depth. And we have here on these diameter drills with different depth also. For all of them we can set up here in depth edit a different ending, a cutter tip, a full diameter, the diameter value for each one of them or for all, and also a delta for start should be 0. All, yes, on delta dip -1. And simulate. As we see, I told you I always prefer to work on this side because of lack of space in the right side. So in our operation we can always select the first angle pair or second angle pair. Start drilling, inside, also rotating the part, all this in one operation. So my part is finished on this side. Of course, we didn't drill this those holes. We can add a new operation and drill them. Now, setup number 2, I will connect spindle and table, this submachine, with Mach 2 position 1 and clamping fixture for a different clamping fixture for a milling table. We have also X, Y, and Z offsets. Those values are similar to values that you have on work offset table in the controller. When you define a home, for example, a G54, G55, you have X, Y, and Z, also B and C. For us, B and C, they are always, we start with them on 0, and X, Y, and Z, we use them as to position the part in machine world, machine space. So I connect now in the first setup, the spindle with rotary table was connected to Mach 1 position 1 with a clamping fixture with 10 shifts. Now the submachine spindle with the table, it's connected to Mach 2 position 1, defined on other side, and we define where is this coordinate system in the machine world. In this way we can position the part in machine simulation and also calculate if the toolpath that we generate is in the machine limits. If not, we will get a message when we generate G-code. Okay, I have this job to recalculate. I make the change in multi-axis drill, and 3D machining always use the rest material, so our rest material was changed. And let's go to simulate and see the part on a milling table. Now the part is on milling table. Here we can use 4 axes, X, Y, Z, and axis B. If I have something to an operation to define from the left side or from any side around Y-axis. I will start to remove the material around that we have left here in the previous setup. Let's make the simulation to stop on operation change. I remove also material on here on this step down. Next operation, I will use a HSM horizontal machining to remove material on the face. Go faster. And a 3D rough eye machining to remove this material here and here also. Next operation, I will start finishing. And internal. And now a 2DI machining on this pocket. And also a finish with a tool that fit to the corner radius. Drilling on the face. And we can say that we finished the part. Of course, you can add a lot of more operations for chamfers to make this part real. But here what we want to show is how to work on different tables with different setups on a large machine, with a big machine with a large table. You can make a lot of, to define a lot of fixtures on the table and a lot of setups. In one programmed part, you can generate G-code for 3, 4, there are unlimited parts processing program. So what we done today, it's only to see how to use the best. I show you how to use the best the tool mounting in turning operations and approach and retract point, very useful options. Use tools with STL and Chunk. It's very easy to download them, and this is free from the tool manufacturer website. And this way you have a real simulation with real collisions. You can detect collisions real. Define a second setup, move the part to the milling table and continue to work. That's the standard procedure on milling machines with turning option. And I finish here, I think, yes. Thank you for listening, and I will see you in the next webinars.
Thank you, Florian, for this presentation. I think we don't have any questions. So thank you, everyone, for joining us, and I hope we will see you also next week. Have a nice week.
Bye, everybody.